Hello everybody, welcome back to my channel, and in today's video I'm going to be talking about the potential storm forming in the Indian Ocean here for the next 5 days. And I'm going to be showing you what the GFS is showing and what the ACM is showing, and I was showing you if there be any dry air around, or like what the wind shear be like, and like would it be favourable to form and favourable for it to develop, and how strong I think it'll get. So we'll start with the GFS, and it's the 12Z run, so it's just updated really recently. And at the moment it just looks pretty just like pretty like showery in nature for like this area, and there's not much going on really at the minute. But as we go on into the beginning of next week, you can see there's a broad area of low pressure starting to form in the Indian Ocean here. And what you have to remember is as well, in this area the sea surface temperatures are like 32 degrees, so it's the hottest area now in the world. So the oceans around this area are like the hottest. There's no other parts of the ocean right now across the world that is hotter than around here. So this could be a scenario where it could explosively intensify. The ocean temperatures are extremely favorable, and I'll show you at the end of the video. So as we go on into Tuesday, then into Wednesday morning, you can see it's rapidly intensified to 952 millibars, and this could be underestimating it because the sea surface temperatures are really favorable. But at this point, if this is right, at this point it'll be a high-end Cat 3, maybe approaching Category 4. And then as we go on into Wednesday evening and then into Thursday, it just continues on the southwest track here, and it's around the 947 millibar range. So it could be around a Category 3 to a Category 4. Then as it continues on the southwest track, it starts to weaken as it goes southwest. Then we've got another system behind it coming out of the Gulf of Carpentaria, and then it starts to come southwest into the Timor Sea, and then it goes into the Indian Ocean. And you can see it explosively intensifies as well in the similar area. And normally when storms go over like obviously a certain parts of the ocean, it sucks up all the moisture and all the heat content, the latent heat out of the oceans to fuel the system. So this storm is going over that area, so like you would think, oh well, it's got less fuel, so then it might not intensify that much more. But then what you have to remember is the ocean heat content around this area is really high as well. So the 32-degree temperature isn't just the skin in the ocean, like it's really warm at depth as well. So like when like the storm here takes that heat away, once it exits, the heat that is stored more at depth, it'll start to surface towards the skin of the ocean, and it'll be like replaced like basically instantly. So like this second system it'll be able to intensify just like the first system. Like there'll be plenty of heat in like moisture around for it to intensify, and it's like a similar strength according to the GFS with this first system. So it's around the 948 millibar range, so potentially Category 4. Then as it continues more towards the southwest, it just stays at a similar intensity. Then as it gets towards the middle of the month, it starts to fizzle out in just the open ocean. But we don't really want to focus too much on this system, the second system, because it's a far range, but it has been consistent on the past few runs. So we'll just have to wait and see. So the GFS for this first system, as you can see, takes it towards the southwest and it doesn't really affect anyone. But like as I'll show you with the ACM, that has got a totally different scenario. But first we're gonna look at the wind shear. So when this like system develops, yeah, in the Indian Ocean, as you can see, once it develops, there isn't much in the way of like wind shear. It's just pretty broad. But then like when it really starts to intensify, as you can see, there's no shear at all, and it's actually opening a dual outflow here. You can see there's an outflow going towards the northwest and the south. So what this means is when there's a dual outflow, it's able to breathe more. It's able to replace the old latent heat, and then like replace it with more latent heat, and like just it's able to ventilate, and that it's just like able to sustain itself and like gain like energy like easier and more efficiently. Then as you can see, the outflow just like starts to become more pronounced. There may be also slightly hint of maybe shear towards the northeast here, but it's not too much to affect it. As you can see, it really starts to intensify it, and the outflow looks like predominantly really good. So this storm could like pose a threat, well, like a threat of like rapid intensification. Obviously, it's still 5 days out, 6 days out, so we can't really say, oh, it's going to rapidly intensify. But most storms these day and age, if it's favorable and the heat's there and the wind shear's low, and if the dry air is not really around, it can rapidly intensify. And like most storms are prone to doing that in this in this kind of like modern era now. Same with this storm. Actually with this storm, and it's obviously too far out, so we can't see what the conditions will be exactly like. But if this was to play out, there's absolutely no shear whatsoever. It's just got its own atmosphere. It's got an extremely good outflow. And like just like the wind shear just around it just looks really favorable. And it's just got really healthy outflow. So there's nothing much in the way of like stopping this if it forms. But obviously we won't put too much attention onto the second storm because it's too far out. But the first storm does look like it will form. It's just a matter of how strong and like well track. Then if we look at the 10-meter winds here, so as you can see at max strength, it's around category 4 intensity. So in like normally like the GFS, well, like especially when the atmosphere is favorable and the ocean heat content's favorable and the SSTs are favorable, normally gets they're normally underplayed, so it could get stronger than this really. Then if we look at the relative humidity, so if you look at the green, the turquoise green here, that's basically moisture. So like if this is a cyclone that forms and it's surrounded by green, that's basically saying it's got loads of moisture and it's like able to form. But like if there's any like bits of brown or known as dry air, if that gets entrained into it, then that could disrupt the system, disrupt the core, and then it won't be able to form at all. So as we could see when it starts to form here, towards the beginning of the week, there seems to be not too much dry air at all, like where the system forms. So the relative humidity, if I was to click here, anything above like 60 to 65 is pretty decent. And at the minute, about like around the area, it's like 92%. So relative humidity is really favorable. And when it forms, there's basically no dry air whatsoever. It just looks like wind shear will be relatively low throughout its whole lifespan. The dry air won't be that much of a problem. It just looks like it has like a favorable environment, but towards the end of its life cycle, it could become more annular because you could see the dry air starting to wrap around the cyclone here. So, if this is the plan off, there won't be much spiral bands. It'll just be a solid like circle domed cyclone, and there won't be much like spiral bands or like rain bands. So at the start of its life, it'll be in like a proper cyclone with like rain bar features and that. But as it goes on, the dry air will sort of wrap around the the cyclone. So then it'll become more of an annular storm. And then as it goes on, it just gets ripped to shreds by the dry air. Then this other system will become annular as well. As we can see that the dry air is starting to wrap around the cyclone. So if that was the plan off, that would be the same as the first one. Like that would become an annular cyclone. But obviously it's too far out, and like we won't like focus too much on the second system. But like it is showing it quite consistently. So now the ACM here. So we'll look at the vorticity. So obviously the darker like the coloring and like the more concentrated it is, the more well defined it is. So like look at this storm here, for example, quite concentrated and like there's quite a lot of spin. So it's like quite a well formed cyclone. So like around this area at the minute, it's just quite sporadic. It's just a broad area of spin, so there's not much going on. But as we go on, you could see with the ECM, it's a lot more east, and it's going like basically due south. But with the GFS, it was taking it southwest. So the ECM is taking it more south, and it's weaker. And then it starts to take it more towards the southwest. But it's a lot more weaker. But the difference is this makes landfall in Western Australia, and the ACM, interestingly, has been really consistent. So look at the So like look at the 12-12-0 run, that makes landfall as well. Then if you look at the most recent run, that makes landfall as well. Also the ACM starting update, but as you can see with the 12-0 run, 3 updates ago, you could see it makes landfall as well. And then the 0-0 run, that makes landfall, and then the ACM sort of updating as well. So and like well, so the new ACM's updating as well. So there's really so there's lots of confliction of where it'll go. The TFS says it going west, southwest, and the ACM is showing it going southwest. So like there is a big divergence in like well goes. So actually I'll show you what the pressures looking like around the systems. So if we look at the GFS here, so go on if we go on the MSLP normal anomaly here, so obviously the darker the blue and the more the low pressure, and like the more red it goes, the like the higher the pressure. So if there's a high pressure just say around this kind of area here, then like basically it can't go west, it has to move south, because like cyclones and typhoons and hurricanes and low pressures, they can't go through the anticyclone. They have to they can't go through like high pressure. They have to go like south of it, east of it. They just can't go through it. So like with this there isn't much in the way of high pressure it looks like at all. So it just has the route to just go southwest. Is as you could see, there's high pressure around here, so it's just going just basically west southwest, and then as we go on it just continues on like the southwest. And then with this system as well, there's not much of a steering current, so like it just carries on in like a similar direction. If we look at the sea surface temperature anomalies here, so around the Indian Ocean, you can see it's well above average. It's between 3.6 and 4 degrees above average. So as I said, like this is the hottest area in like the world. So there's no other ocean basin in the world that is warmer than here. So like this has plenty of fuel to develop. So as you can see, there's 32 degrees. There's probably sporadic 33s around in the area as well, and that's in the path of the track as well. So I wouldn't like rule out a strong cyclone forming at all. So yeah, guys, I hope you enjoyed this video and found it informative. Please like and subscribe and turn on the post notifications so you don't miss an upload. So yeah, I hope you enjoyed it. I'll see you in the next day or two.